Welcome to the discussions on the past year questions. This video, we shall take a look at the further maths paper May-June 2023, paper 13. Okay. Let's take a look at the first questions. Prove by mathematical induction that for all positive integers n, 5 to the power of 3n plus 332 power of n minus 33 is divisible by 31. So first of all, we just start from n equal to 1. When n is a 1, then this one will be 5 power 3 plus 32 minus the 33. So you will get the answer as 124. And by using calculator, you can see that 124 is actually a 31 multiplied by 4. So therefore is divisible by 31. So this one is true for n equal to 1. Then we assume true for n equal to k, which is 5 power 3k plus the 32 power k minus the 33 is divisible by 31. Okay, so this is the second statement. Now the third statement, we want to let the k equal to 1. Okay, before we let n equal to k plus 1, first of all, we just let this one call the fk. Okay, just let this whole function over here, we call it fk. Change all the n become k. Then k plus 1. So when n equal to k plus 1. Okay, so this is what we need to do. This one will be 5 power 3 bracket of k plus 1 plus the 32 power of k plus 1 minus the 33. So we already know that this one is divisible by 31. What we need to do is to show that this is also divisible by 31. And what we can do over here is we just minus it. Just take the fk plus 1. Okay, just take the fk plus 1 minus the fk. Then you get 5 power 3k plus 3 minus the plus the 32 power k multiplied by 32 minus the 33 minus the 5 power 3k plus the 32 power k minus the 33. So what you can see is that this part minus with this part, you will get 124. Okay, so this one you will get 124 multiplied by 5 power 3k. Then this part minus this part, you will get 31 multiplied by 32 power 3k. Power of k. So this one all can be factorized at 31 out. Then you get this one as a 4. Okay, so this is the multiple of 31. So from here, because this is a multiple of 31, divisible by 31, this one is also divisible by 31. So since both of them are divisible by 31, that means the fk plus 1 is also divisible by 31. So what we can do here is just write fk plus 1 is equal to the fk plus the 31 of this. So it's divisible by 31. Therefore, true for n equal to k plus 1. Then conclusion, by BMI, the 5 power 3n plus the 32 power n minus the 33 is divisible by 31. For all positive integer n. Just like that, done. So this will be the answer. This will be the suggested solution for the question number 1. Okay, so now we take a look at question number 2A. Use standard result from the list of formulae MF19 show that the sum of the series is equal to the an cubed plus bn squared plus cn, where a, b, and c are integers to be determined. Okay, so what you need to do is just first of all, write this whole thing down. 6r squared plus the 6r minus 5. Then just expand them accordingly, make it like this. Apply the properties of the series. So for the first series, you will get this one as an n plus 1, 2n plus 1 over 6. This one is actually, we can get it from the formula booklet, MF19. This one is a 6, then this one is n plus 1 over 2 minus a 5n. So we simplify first, and you can see that you have n plus 1, 2n plus 1 plus the 3n, n plus 1 minus a 5n. So from the questions given, they actually want you to expand everything. So we just follow the instructions. You have 2n cubed plus the 3n squared plus the n plus the 3n squared plus 3n minus a 5n. Simplify further, you have 2n cubed plus the 6n squared plus the minus n. Okay, it's a minus n. So from the question given, therefore, your A is a 2, B is a 6, and your C is a negative 1. That will be the answer for the 2A. Now we move on to the 6B. So for 6B, they asking you to use the method of differences. So when we must use the method of differences, there will be subtractions between two terms. So this whole thing is in one term, and usually we need to use partial fraction to solve it. But you can see that this is improper fractions. This is improper fractions. So for these improper fractions, what you need to do is to make it become proper first. So to make it proper, 6r squared plus 6r minus a 5 over the r squared plus r. So I make it like this. Okay, so I just group them like this. Then this will be 6 minus a 5 r squared plus r. R squared plus r actually can factorize it. So the denominator here, I factorize it, become r plus 1. And we can actually direct do the partial fractions over here. We can take the 5 out. And this will be this. Okay. So that means this one can be written as 5r plus the 5 over the r plus 1. Okay. So now the sum of the series, 6r squared plus 6r minus a 5 over the r squared plus r can be written as this. Okay, so we just need to replace r equal to 1 inside. For r equal to 1, you get this. Then when r is equal to 2, when the r is equal to 3, so from here you can see that the 6 over here, it will remain as a 6 plus 6 plus 6 plus 6 until n terms of it. Then only the terms that over here that is involving r, they can change from time to time. Okay, so we can just start from r equal to 1 and then r equal to 2 and so on and so on. But what we can observe is that from here we can see the pattern that this can be cancelled off. So if you can see the pattern, that means if the pattern follows, we just need to show until the last two terms. All the patterns will behave in this way. So this one, the last term here will be, the last term, of course, it will be 5 over n plus the 5 over the n plus 1. So this one will be 5 over the n minus 1 plus the 5 over n. So you can see that it will cancel it in this way until like this. So over here, you will have 6n minus the 5 plus the 5 over n plus 1. This will be the sum. Okay, this will be the summation. Okay, so we consider done for this question number 4. Question number 2b. Okay, so now we move on. C. They want you to find the sum of the series from n plus 1 to 2n. Okay, so we just make use of the result that we have here. Let me just copy down the result. This is the result that we have found just now. 6r squared plus 6r minus a 5 over the r squared plus r is actually 6n minus a 5 plus the 5 over n plus 1. So now the questions, according to the questions, they give you 2n, r from n plus 1 until 2n. So this one we can start from, we can just say that it's from r to n. Okay, minus the from 1 until 2n, from n until n, from 1 until n. Okay, so this is what we have. Then this one, just replace it, become 2n. This one is just copy down the answer that we have earlier. So you can see that this can cancel, and you are having 6n plus the 5 over 2n plus 1 minus the 5 over n plus 1. Okay, so this is what we have, the answer. Of course, you can leave it like this. The question didn't mention any particular form, but you can also combine them together if you want to. You can combine them, become 5n plus 5 minus the 10n plus minus 5. You can actually combine them if you want to. So this one, you will get this one as a 6n minus the 5n, 2n plus 1, and n plus 1. This one is not necessary. Yeah, actually, this one is good enough. Okay, over here, the answer over here is good enough. Okay, over here is good enough. So because this one question only 2 marks, so there's no need for you to write so detailed. Okay, so that will be the answer for the C. Now we take a look at question number 3. The equations x power 4 minus the x squared plus 2x plus 5 equal to 0 has the root alpha, beta, delta, gamma. Find the quadratic equation whose roots are alpha square, beta square, gamma square, delta square, and stated the values of alpha square plus beta square plus gamma square plus delta square. Okay, So first of all, we just let the y is equal to x squared. That means the x is equals to the positive, negative set y. But we have learned that for these substitutions, if we want to use a substitution method to form a new equations, usually for the square root, we just consider the positive, we don't need to consider the negative. Okay, because later we want to square it, then the negative will become positive. Okay, so this is what we have. Then I just need to replace the x inside here, each and every one here, equal to 0. Expand, simplify, then you'll get the answer. So for the x power 4 minus the x squared plus the 2x plus 5, now I have this one will become y squared minus the y plus the 2 square root of y plus the 5 is equal to 0. So what I'm having is a 2 set y is equals to 2 set y is equal to the y minus the y squared minus the 5. So square both sides, then you get this square. So the square over here, I just straight away write like this. So over here, you have to expand your right hand side carefully. So you have a y square minus a y cube minus a 5y minus a y cube plus the y power 4 plus the 5y square. Then minus a 5y plus the 5y square plus a 25. So simplify the whole thing. You will get this as the, okay, so I will simplify it. Make one side become 0. I will get y power 4 minus the 2y cube plus the 11y square minus the 14y plus the 25 equal to 0. So therefore, these equations will be representing the, this equation will be representing the new quadratic equation that the root is alpha square, beta square, gamma square, and delta square. So for the whole equation over here. Okay. Okay. So this, the root will be this. Okay. So now we want to find the alpha square plus beta square plus gamma square. So actually, this is a minus. Okay. So therefore, your alpha square plus beta square plus delta square plus gamma square plus delta square is equal to 2. Just like that. So it's actually the value here. So now, move on. Question number B. Find the value of 1 over alpha square plus beta square plus 1 over beta square plus 1 over gamma square plus 1 over delta square. So over here, usually I will suggest you to, from here, I will divide everyone by y to the power of 4. Okay, so from here, y power 4 minus the 2y cube plus the 11y square minus the 14y plus 25 equal to 0. I divide everyone by y to the power 4. Then I will get 25. I will write like this. Then this one is minus the 14 y cube plus the 11 y square minus the 2 plus the 1 equal to 0. So now all the equations over here, the root will be 1 over alpha square, 1 over beta square, 1 over delta square, gamma square, and 1 over delta square. Okay, so this is what I am trying to do. Okay, so from here, to find the sum of this, I need to divide everyone by 25 as well. Then I get this. One over y cubed plus the 11 over 25, 1 over y squared minus the 2 over 25, 1 over y plus 1 over 25. Okay. Then therefore, your 1 over alpha square plus 1 over beta square plus 1 over gamma square plus 1 over delta square is actually equal to the 14 over 25. Okay, so that will be the answer for the part B. Then now we go for the question number C. C, this one is power 4. Okay. So for power 4, actually we can do it. Yeah. Okay. I think I will do it. There are two ways to do it. Okay. So I think I will use this way. From the x power 4, plus beta power 4 plus gamma power 4 plus delta power 4, you can use a formula alpha square plus beta square plus gamma square plus delta square minus the 2 times the alpha square, 2 times the alpha square beta square plus alpha square gamma square plus alpha square delta square plus the beta square gamma square plus the beta square delta square plus the gamma square delta square. Okay, then this will be equals to, this one is a square. It will be equal to the 2 square minus the 2 times the 11. Then at the end, you get the answer as 4 minus 22. You get negative 18. This is one of the way. This is one of the way. Okay. So maybe we can have another way. So another way is that from the equations x power 4, from these equations, from this equation over here, I just need to bring all of them here, go to the other side. Then you get x power 4 equal to the x squared minus 2x minus 5. X power 4 is equals to the x squared minus the 2x plus 5. So your alpha power 4 plus beta power 4 plus delta gamma power 4 plus delta power 4 is actually alpha square plus beta square plus gamma square plus delta square minus a 2 of the alpha plus beta plus gamma delta plus the 5 multiplied 4. So this one we already found this answer is a 2. Then this alpha plus beta plus gamma from the equations, actually this one is a 0. Then this one is the I make a mistake. This is a minus 5. Okay, this is a minus 5. Then it will be correct. So this one will be minus a 20. So at the end, you get 2 minus 20, you get negative 18. So now the answer is the same. This answer and this answer are the same. Okay, so done. That will be the answer for the question C. Okay, now we take a look at question number 4. The matrix M is given by this, where the data is between 0 to pi. K is a constant non-zero constant. And the matrix M is a sequence of two geometrical transformations, one of which is a shear. Okay, describe fully the other transformation and state the order in which the transformations are applied. So you can see that actually this one you need to memorize the formulas of the transformation. So obviously this one is shear and this one is rotation. Okay. So what you need to do now is to describe what is the rotation all about. So this one just tell that this one is a rotation. Anti-clockwise, need to tell the directions of the rotation. About origin with the angle 2 theta. Okay, so that is the descriptions of the other transformation. Then now, they want you to state the order. So the order will be shear first. Shear in x direction. Followed by rotation. Basically, just copy the sentence that we have written down in the earlier sentence. So just tell there's rotation anti-clockwise about origin. Through angle 2 theta. Just like that will do. That is the answer for part A. Then for the part B, you are having an M inverse. So we just let this one call A, the rotation call A. Okay, so this matrix is represented by A. And the B is represented by the shear. So in order, your M, that means the M is actually A times B. So your M inverse is actually AB inverse. Then it will be B inverse multiplied by A inverse. So how do you write down the inverse of A? So the inverse of A is the determinant 1 over the cos square 2 theta plus the sine square 2 theta. Okay. Maybe I should write down the A inverse first. A inverse is this. This one change it to negative. This one change it to positive. This one change it to this one still same. So you know that it's a 1. Okay. So you know that it's a 1. So your A inverse will be like this. Cos 2 theta, negative sine 2 theta, sine 2 theta, and cos 2 theta. Then your B inverse, it will be also a 1 over 1. Then this one is a 0, negative k, 1. Okay, then you can write it down as this. Okay, so from here, you already have the matrix inverse of A and inverse of B. So this one can be written as 1, 0, negative k, 1 multiplied by cos 2 theta, negative sine 2 theta, sine 2 theta, and cos 2 theta. So that will be the answer for the B. Then as for the C, they want to find the value of K, so that, or they want to find the value of tangent theta in terms of K, where the M minus I is a singular. So first of all, we need to multiply the M, the two matrices of this M, make it become 1. So the M is actually cos 2 theta, sine 2 theta, negative sine 2 theta, and cos 2 theta multiplied by 10k1. So if you multiply it, you will get this one as a cos 2 theta, sine 2 theta, k cos 2 theta, minus a sine 2 theta, divided by the k sine 2 theta, plus the cos 2 theta. Okay, then m minus the I, it will be, the I is actually the identity, is a 1001. So basically the diagonal of the m, just everyone minus with the 1. So it will be cos 2 theta minus 1, sine 2 theta. Then this one is a k cos 2 theta minus a sine 2 theta. This one is a k sine 2 theta plus the cos 2 theta minus 1. Okay, so this is what we have. Then in order to be singular, your determinant of the m minus the I must be a 0. So to find the determinant, it will be a bit troublesome. So over here, we just need to do the formula. This multiplied by this. Then minus with the sine 2 theta of k cos 2 theta minus a sine 2 theta equal to 0. So you need to aware that this and this are the same. So I will expand it in this way. K sine 2 theta cos 2 theta plus the cos 2 theta minus 1 square minus the k sine 2 theta cos 2 theta plus the sine square 2 theta equal to 0. So you can see that these two are the same. They can cancel to each other, make it become 0. Okay. So I straight away cancel it. Then I need to expand this whole thing because what I have is 2 theta, but the questions that they want is only tangent 1 theta. So I expand this first. I get cos square 2 theta minus the 2 cos theta, 2 cos 2 theta plus 1 plus the sine square 2 theta equal to 0. So you know that these two together must be a 1. It can be a 1. So then you will get 2 minus a 2 cos 2 theta equal to 0. Okay. So wait for a while. Okay. Oh, I make a mistake. This one, when I multiply inside, I forgot there's another k sine 2 theta. Okay. So my apologies. I need to write properly, else it will be very messy. Okay. So miss out one terms over here. So this one just now when I multiply inside, I'm supposed to get this. So I think it's better we write it more carefully. So we have a cos 2 theta minus 1 multiplied by k sine 2 theta plus cos 2 theta minus 1 square minus a k sine 2 theta cos 2 theta plus the sine square 2 theta equal to 0. So I expand properly as usual. You can see that this part, if you expand, you can cancel with this. So I straight away cancel it. I think to be safe, we just do it one by one. Minus a k sine 2 theta plus the cos square theta minus 2 cos square 2 theta minus a 2 cos 2 theta plus 1 minus a k cos 2 theta sine 2 theta plus a sine square 2 theta equal to 0. So you can see that this one can cancel off. Then these two can become a 1. So at the end, you will end up with this. Okay, you end up with negative k sine 2 theta plus the 2 minus the 2 cos 2 theta equal to 0. So this one I can make it become 2k sine theta cos theta. This one I can make it become plus 2 minus the plus minus the 2 multiplied by 1 minus the 2 sine square theta equal to 0. Okay. So you can see that all of them have a multiple of 2. All of them have a multiple of 2 here. Okay, you can see that this one is a multiple of 2. So it's a multiple of 2. Multiple of 2. So all the 2 can be cancelled off. So what you can do now is you have negative k sine theta cos theta, then plus the 2 sine square theta equal to 0. Factorize the sine theta out, then you get 2 sine theta minus a k cos theta equal to 0. So you get sine theta equal to 0, or the 2 sine theta minus a k cos theta equal to 0. Okay, so this one ignore. What is the reason you want to ignore? Because the theta is between 0 to pi. Okay, the theta is between 0 to pi, so you ignore the sine theta equal to 0. Therefore, you will be having tangent theta is equal to k over 2. Done. That will be the answer for the part C. A bit troublesome, just have to be careful when you expand them, because it's involving a lot of trigonometry identity. So have to be more careful when you expand them. Okay, so now we move on to the part D. Given that the k equals to the 2 sub 3 and the theta is equal to pi over 3, show the invariant points of the transformation represented by m lies on this line. Okay, so we already have the m just now. So the m that we have just now was here. This is the m. So you're going to change all the k to become 2 sub 3. Change all the theta here to become pi over 3. Okay, so we just direct substitute in. So you will get this one as the cos 2 pi over 3. Okay, cos 2 pi over 3 and sine 2 pi over 3. So k is a 2 sub 3. Cos 2 pi over 3 minus a sine 2 pi over 3. Then this one is a k sine 2 pi over 3 plus cos 2 pi over 3. Okay, so you simplify them, you will get this one as a negative half. This one is a sub 3 over 2. This one is the negative sub 3 minus the sub 3 over 2. This one is the negative 3. This one is a this one is 3. This one is minus the sub 3 over 2. Okay. So if you wait now, this one is not sub 3 over 2. Cos 2 pi over 3 is actually a negative half. Okay. So if you simplify further, then this will become negative half sub 3 negative 3 sub 3 over 2, and also this one will be 5 over 2. Okay, so this will be the matrix M. And now we are ready to find the invariant lines. So just negative half, sub 3 over 2, negative 3 sub 3 over 2, and 5 over 2. Multiply by x mx equals to the x mx. So you get negative half minus the 3 sub 3 over 2m equal to x, and sub 3 over 2 plus the 5 over 2m. X is equal to mx. That is equation 1. That is equation 2. Take the equation 1 divide by 2, or the 2 you divide by 1. Then you will get this. So 3 over 2 plus the 5 over 2m divided by negative half minus the 3 sub 3 over 2. Equal to m divided 1. So simplify them, you can get sub 3 plus 5m is equals to the negative m minus the 3 sub 3 m squared. Then you will get 3 sub 3 m squared plus the 6m plus the sub 3 equal to 0. Use a quadratic formula. Negative b plus minus of b squared minus a 4ac divided by 2a. Then you will get only 1. You will get this as the negative 1 over sub 3. Negative 1 over sub 3, it also can be written as a negative sub 3 over 3. It depends on what is the situation, what is the expression that we want. Okay, so therefore your invariant lines, it will be only one. You have only one m, so you have only one invariant line. It will be y equal to mx. If you written it in this way, then it will be sub 3y plus x equal to 0. Okay, but the questions, they want it to be like this. They want it to be like this. Okay, so then means we will use this negative sub 3 over 3x. So it will be 3y plus sub 3x equal to 0. Is this what they want? Yes, correct. So that will be the answer for the 4D. Okay, now we take a look at question number 5A. Show that the curve with the Cartesian equations, this has the polar equations of r squared equal to the a secant 2 theta. Okay, so for this question, usually we just need to remember that x is equal to the r cos theta, y is equal to the r sine theta will do. So just replace them inside here. Then you will get this as the x squared minus the y squared equal to a. That will be r squared cos squared theta minus the r squared sine squared theta equal to a. That will be r squared cos squared theta minus the sine squared theta equal to a. And you need to understand that this is actually cos 2 theta equal to a. So it will be r squared equal to the a over the cos 2 theta. Then it will be the same as the a secant 2 theta. Shown. That will be the answer for the number 5A. Then for the number 5B, they ask you to sketch this curve and 0 to pi over 4. Okay, 0 to pi over 4. So for this question, usually we will recommend you to draw a table to fill up the value. Okay, usually we try to draw a table to fill up the value. Theta and then r. Okay, so you can put 0 inside. If you put 0, then you will get this as square root of a. And then when you put pi over 4 inside, you will get secant pi over 2. Secant pi over 2 is infinity. So this one is it's infinity. So that means this will be your asymptote. Okay, this will be your asymptote. Theta equals to pi over 4 will be asymptote. Then we need to have some value here. Okay, so we need to have some value here. Maybe you can put pi over 3, pi over 6, not pi over 3, yeah. Pi over 6. Over here, we need to put a value pi over 6 inside. Okay, so over here, if you put pi over 6, then you get secant pi over 2, secant pi over 3, secant pi over 3 is a square root of 2a. Okay, this one will be square root of 2a. Okay, so if you sketch the diagram, this is a theta equal to 0. This is the theta equals to the pi over 4. Then this one is 30 degree. Theta equal to the pi over 6. So add here set 2, set A. Then add here is a set 2a. Then this one is infinity. So it will be like this. So the curve will be somewhere. Okay, so make it nicer. So the graph is supposed to be like this. Oops. Since I draw in freehand, it's not really easy to draw the graph nicely. Something like that. Okay. So make sure the features of asymptote is proper. Make sure the features of asymptote is proper. Okay. My apologies. Anyhow, you can refer to the mark scheme. They will provide you a nicer graph. There, that should do it. Okay, so that will be the graph for the B. Okay, done. That is a y, and that is a 0. This is the theta equal to the pi over 2. Okay, so now we move on to the part C. But the questions, they also want to find the minimum distance from the pole. So the minimum distance from the pole will be set A. This is the minimum distance. Okay, done. Then now we go for C. Find in terms of A the exact value of the area of region enclosed by C, the initial line and the half line. Theta equal to pi over 12. You may assume the result from the list of formula booklet MF19 without proof. Okay, so there we are allowed to use the formula in the formula MF19 to do the integration. So the area is half from 0 until pi over 12 r square d theta. So since the r square, we already know the r square is a secant 2 theta. So this one, it will be a secant 2 theta d theta. Okay, so a secant 2 theta d theta, you can actually take a a out. Secant 2 theta d theta. So we can use the formula in the formula booklet. So with this one, we need to use the formula booklet MF19 and we need to search for it. Okay. So the formula booklet, let me just do it for a while. Let me search for this formula. The formula that we can use, that means we want to know how to integrate secant. Secant. Okay. So from the formula booklet, under the page 6, okay? So if you go for the formula booklet MF19, page 6, Okay, so if we go for page 6, MM19, page 6, so you can have integrate secant x. The x will give you ln of modulus tangent half x. It's pi over 4. Okay, so this is the formula that I will be using. So we just integrate it. Okay, so you get the ln modulus of tangent. So your half x are your x become 2 theta. So your x become 2 theta, then it's going to become theta plus pi over 4. Okay, but there's a 2 here. Okay, so there's a 2 here, so you have to divide by 2. Okay, so this will be the integration, and you want to put the 0 and the pi over 12 inside. Okay, so to put this one, it will be a over 4. Then it will be ln pi over 12. You get pi over 12 plus pi over 4. Then you get 4 pi over 12 ln tangent of 4 pi over 12 minus a ln tangent of pi over 4. So tangent pi over 4 is a tangent of ln tangent pi over 4 is a ln 1. So ln 1 is a 0. So you will get this one as a ln pi over 3. Tangent pi over 3. Tangent pi over 3 is a ln sub 3. Okay. So ln sub 3, usually we will not giving the answer like that. We can just bring the half out. So it will be a over 8 ln 3. That will be the answer. Okay. So in case some of you are questioning how to get the half, how to get the half over here, So maybe we can explain a little bit here about how to get the half. Okay. So basically, by using this result from the formula booklet MM19, we just let our x as a 2 theta, then your dx d theta will be a 2. So your dx will be a your half dx will be a okay. So your dx will be a 2 d theta. Okay. Then over here, integrate secant x dx, it will become integrate secant of 2 theta 2 d theta. Okay. Then integrate this, you will only get ln of modulus tangent theta plus pi over 4. But the question over here is secant 2 theta, no 2. So these 2 have to go to the over here, then it will become divide by 2. Okay, that is a reason. There is a reason behind it. Okay, so but in exam, if you can remember the answer, if you can remember the process, then you can just straight away divide by 2. Just straight away divide by 2 here will do. Okay, so this one's just something extra for you to refer. So move on. Okay, now we take a look at the question number 6. Vector. The point A, B, C have the position vector given as such. Then they are all respectively and relative to the origin O. So we can write this one as a OA, 110, OB as the negative 124, and OC as a negative 213. Okay, we can write it in the matrix form like this. Then we want to find the equations of the plane ABC. So I just need to find the directional vector of AB. Just take B minus A, you get this. And then directional vector of AC, just take C minus A, then you get this. So what you need to do now is do the cross product between AB and AC. So -214, -303. Just do the cross product. You will get 3i minus the 6j plus the 3k. So I can factorize the common factor 3 out. So this one, it will give me the, this one, it will be, just take the basic vector will do 1, -2, 1. The multiple 3, you can ignore it. So therefore, my normal vector for this plane will be 1, -2, 1. So since I have the equations, since I have the normal vector already, equations of plane, it will be the dot product over here. So usually we just put 4 brackets. This will be your normal. Normal over here. This is a x, y, z. Then this is a position vector. The position vector, you have 3 options. You can choose any one of it that you like. So I choose the first one, A. And you get x minus the 2y plus z is equal to the 1. This one multiply, you get 1. This one multiply, you get -2. This one you multiply, you get 0. So 1 minus 2 plus a 0. So you get a -1. Okay, so this one is a -1. Done, just like that. That is the answer for the part A. Not so bad. So now we go for B. Find the perpendicular distance of from O to the plane ABC. So this one is quite straightforward. So the plane ABC, just write the plane over here. This plane, I will write it like this. ABC, I write it like -2y plus z plus 1 equal to 0. I make it equal to 0. So I have my x, I change it to 0. My y, I change it to 0. My z, I also change to 0. Then divided by the square root of the coefficient of x, coefficient of y, and coefficients of z. Okay, just like that. So use your calculator. You can write the answer in 1/6, or you can give it as a 6/6. Done. That will be the answer for the question number 6, part B. Okay, so now we move on to the question C. Find the vector equations of the common perpendicular to the lines OC and AB. Line OC and AB. So we need to find the line OC. Line OC, actually, we already have. Line OC, we already have that the OC pass through the O. Okay, so this one I call the parameter I use D. C is the directional vector. OC we already have earlier. OC is over here, -2, 1, 3. So -2, 1, 3. So basically this one you can ignore. So we can just write it as, just write it like this. Then AB. This one you can choose S. The directional vector of AB we already have just now. AB, -2, 1, 4. Just use it. Then this one you can choose the point A, you can choose the point B. Over here I choose the point A. Okay, can A, can B, never mind. It's okay. So that is a line AB. Okay. So they say that we let the B lines on the, we let B lines on OC. So if B lies on OC, that means we can say that the OB will behave exactly like this. All the OB will behave exactly like this. Okay, so this one, it will be 2, 1, 3. Then we have an OQ lines on the line AB. It will behave like these two combine of these two matrices together. These two matrices together. So you have a 1 minus 2s, 1 plus s, and 4s. Okay. Then we combine together. to find the PQ. PQ is the OQ minus OP. So if we take Q minus P, then you will get 1 minus 2S plus 2T. Then you will get 1 plus S minus T. Then you will get 4S minus 3T. Okay, that is my PQ. And then PQ is perpendicular. Okay, is this vector equation that have a common perpendicular to the line AB and AC. So that means that we have OC, and then we have a line AB. Okay, then in here we have a P, here we have a Q, and this we have a common perpendicular line that pass through the PQ. This one 90 degree, this one 90 degree. So that means we need to do the cross product. Okay, we need to do the cross product between the OC and AB. Okay, or no need. Maybe we can just say that the PQ is actually dot product with the OC, you will get 0. PQ, the dot product with the AB, you'll get 0. I think this one also can. Okay. So that means that the PQ is perpendicular to OC. That means the dot product of negative 2, 1, 3, you will get 0. Okay. So this is what it means. So over here, if you simplify, you get a negative 2 plus 4S minus the 4T plus, this one is a plus 1 plus S minus T plus a 12S minus the 9T equal to 0. Then over here, if you simplify it, you have 17S minus a 14T equal to 1. Therefore, you have T is equal to the 17S minus 1 over 14. Wow. Not a very good equations, but no choice. That is what we can do at the moment. Then we do the PQ is perpendicular to the AB. That means this PQ dot with the AB, and I'll get 0. So you have a negative 2 plus 4S minus a 4T plus 1 plus S minus a T plus a 16S minus a 12T equal to 0. So over here, simplify it, you will get 21S minus a 17T is equals to 1. I call this equation 2. So equation 1 into equation 2. Then I will get 21S minus a 17S minus 1. So this one we just need to expand, simplify. Okay, so to save time, I just give you the answer directly. My value of S, after I simplify everything, I get negative 3 over 5. So when I found the S, actually I can find the T also, but I do not need to have, I just need to have one of the point will do. Either I just need S or need T will do. So I don't need to find both. Okay. So just now I told you that the line, the equation of line, okay, so this is the OC, this is a B, and this is the A, this is the B, so this is the Q. So this line is perpendicular to OC and AB. So we need to find the cross product of OC and AB. Cross product of OC and AB. So OC just now was negative 213. AB was negative 214. So if you cross product, then you will get this one as the I plus 2j. Okay, so this will be the normal. Okay, the normal will be this. This will be the normal vector. Okay. So I haven't finished yet. Because just now I found the S, then I can, once I found the S, then I can put the X back here. Put the S back here, then I can find OQ. Okay. If you want to find OB, then just find the D and then put it back. So this one, my OQ will be, wait for a while. This one need calculator. I write them in the matrix form. You can write them in decimal also. Okay, so this one is a 2.2, 0.4, and negative 2.4. Okay, so this is the position vector. This is the directional vector. Join together, you have a common line. So therefore, the common line R equals to OQ plus the lambda of the normal vector. Done. That will be the answer for the question number C. Okay. Okay, now we take a look at question number 7. The curve C has the equations y equals to the x squared plus 2x plus 1. We want to find the asymptote of the curve. So to find the asymptote, we have a vertical asymptote. Just take the denominator out, let it equal to 0, then you get x equal to 3. And you know that this is a square, this is a x power 1. The numerator is 1 degree higher than the denominator, so we can have oblique asymptote. So in order to get oblique asymptote, you can use long division, or you can just do like what I usually do is we make it like this. Okay, I make it like this first. Then this one, I factorize it. Minus 3 plus 16. Okay. So this is what I usually do. Then I can make it become x plus 5 plus 16 over the x minus 3. Then therefore, my oblique asymptote is y equal to x plus 5. Okay. So done for the part A. Now we move on for the part B. Coordinates of the turning point. So in order to find turning point, I need to do dy dx. So dy dx, usually we can find the dy dx from here. But if you already have this form, find the dy dx from here, that will be better. More advantage if you factorize, if you find the dy dx from the one that you have reduced to the, if you make it to become to the factorized form, not factorized form, make it become the mixed number form. Okay, so over here, this differentiate, you get 1 minus the 16 over the x minus 3 square. So your dy dx equal to 0, then you get x minus 3 square is equal to the 16. So your x will be a 3 plus minus of 4. So your x will be a negative 1 and x will be a 7. But since you're looking for point, then when x is a negative 1, what is your y? When x is a 7, what is your y? So just use your calculator. X is a negative 1, just put it back, then you will get 0. For the y, this one is your 16. Okay, so these are your turning points. You do not need to mention they are maximum or minimum because the question are looking for turning point. So all of them are turning points. So the turning point will be negative 1, 0 and 7, 16. So remember, no need to confirm maximum, minimum. Just later when you put on the graph, then you can tell that is a maximum or minimum right away. Okay, so that is the answer for part E. Now we want to sketch the graph C. So to sketch the graph, need to draw a proper scale. So I draw in freehand, so it's a kind of difficult for me to draw with a proper scale, but I'll try. Okay. So I need to make it quite small because the value is quite big. So you have vertical asymptote is x equal to 3 and x plus 5. Okay. So 1, 2, 3. Then -1, -2, -3, -4, -5. This one is 1, 2, 3, 4, 5, 6. Okay, so maybe it's kind of difficult. This one is -5. 1, 2, 3, 4, 5. So this is your oblique asymptote. Okay. That is your x. That is a y. So your maximum point is a -1, 0. Okay. We need to find intercept. When x equal to 0, what is your y? Just go back. When x is equal to 0, your y is a -1/3. So when the y is equal to 0, what is your x? When the y is equal to 0, then x squared plus 2x plus 1 equal to 0. That means your x is a -1. Okay, so over here. Okay, so your graph, this one it will be 3. So I think I will just simply roughly show the shape. This is a minimum point, 7, 16. So from here, okay, then this will be a -1/3. That is a 3. So this is the line of y equal to x plus 5. This is the line of x equal to 3. Okay, so this is how you get the graph for the C. Okay, done. Now we want to do the D. D is they want you to do the 2 graph. Okay, then clearly identifying each curve. That means you need to show the features clearly. So for this part, it's actually just reflections. All the negative graph going to become positive. So these reflections actually just need to reflect it like this. Okay, just reflect up. This one just reflect up. Maybe we do it like this. Just reflect up. So the graph would be like this. Okay, so this is the reflections. Reflect up like this. And this one still remain. That is a modulus one. Okay. But I think I cannot write over here. I need to write it on another graph. So this part, this modulus graph, it will be like this. So this is a 3, x equal to 3. Then this is a 5. This is a -5. The oblique asymptote. Okay, so this is the reflections. Okay, then this is the, okay, so this part need to erase it. This part need to erase it. This is a -5. So this one after you reflect, it will be like this. Okay, then your graph it will be like this. This is a -1. Okay, so these are the reflections. So this graph is for the y equal to the modulus. Okay, so this graph will belong here. Okay, so now square. This one is a bit troublesome because this one is got square. So you need to understand that when square, you're supposed to get positive negative square root of x squared plus 2x plus 1 over the x minus 3. So this positive negative, okay, we usually will focus on the positive first. Focus on the positive. Then the negative is actually just reflections about reflects. Okay, reflection about x-axis. Okay, so we focus on the positive square root first, then the negative square root just totally reflect. Okay, so for this case, if you have a square, we are having here, oops, accidentally erased the x-axis, y-axis, okay, accidentally erase the y-axis. Okay, so this one, you need to understand that your oblique asymptote, this is the oblique asymptote when it is a y. But when you are having a y square, then your oblique asymptote will become y squared equal to x plus 5. Then your oblique asymptote will become positive negative square root of x plus 5. So at like what I say, we focus on positive first. The negative later will be just the reflections only. So now the question, the problem is how is the graph of oblique asymptote square root x plus 5 look like? So you all need to understand that square root of x plus 5 is actually like this. It go like a curve. This one is at 5. So this at 5 is actually lower than, because just now this one, the asymptote is 5. But now it's a asymptote is a square root. Not the asymptote, just now the intercept. The y-intercept is a 5. Now for this, if you square root it, your intercept will become square root 5. Okay, so it become lower down. So over here, maybe I need to use, I need to show the features. Okay. So that means what? That means originally your asymptote supposed to be, like this. 5 and -5. But if you make it become square root of x plus 5, then it will become this. It will become y equal to square root of x plus 5. This one is a y equal to x plus 5. So the asymptote, this one is a Z5, already reduced, already lower. Okay, so over here, I also need to make it lower. Square root of 5 is 2 point something. So 2 point something. So 2 point something must be somewhere here. Okay, so your asymptote, I use a different color. Okay, so by right, your asymptote is supposed to be like that. Okay, your asymptote is supposed to be like this. But I do not need this part. Okay, so I just need to draw this value. So this point just now, this point was 7 and 16. So if you have y square, then it will become 7 and then 4. You square root the 16, then you get a 4. Okay, so it will be 7, 4. So it will be going lower down. So it will be somewhere here, 4. So your graph will be like this. Your graph will go lower down, like this. Okay, maybe I draw first. I only plot the point. Okay, now that you reflect to the about the x-axis, then you're supposed to have another one. This is a Z5. Then this will be negative Z5. So your graph will be like this. Okay. Then this one just a reflections. Then your graph, it will be like this. Okay, so this point is actually 7 and 4. This point is 7 and -4. Okay, so that will be this graph will be the y-square of the fx. This graph okay. So done. That will be the answer for this question number 7B. Just like that. Okay, done.